Earth science or geoscience is an all-embracing term referring to the fields of science dealing with planet Earth. It is arguably a special branch of planetary science, though with a much older history. There are both reductionist and holistic approaches to Earth sciences. The formal discipline of Earth sciences may include the study of the atmosphere, hydrosphere, oceans and biosphere, as well as the solid Earth. Typically, Earth scientists will use tools from physics, chemistry, biology, chronology, and mathematics to build a quantitative understanding of how the Earth system works, and how it evolved to its current state. Fields of study. The following fields of science are generally categorized within the Earth sciences. Geology describes the rocky parts of the Earth's crust and its historic development. Major subdisciplines are mineralogy and petrology, geochemistry, geomorphology, paleontology, stratigraphy, structural geology, engineering geology, and sedimentology. Physical geography covers aspects of geomorphology, soil study, hydrology, meteorology, climatology, and biogeography. Geophysics and geodesy investigate the shape of the Earth, its reaction to forces and its magnetic and gravity fields. Geophysicists explore the Earth's core and mantle as well as the tectonic and seismic activity of the lithosphere. Geophysics is commonly used to supplement the work of geologists in developing a comprehensive understanding of crustal geology, particularly in mineral and petroleum exploration. See Geophysical Survey. Soil science covers the outermost layer of the Earth's crust that is subject to soil formation processes. Major subdisciplines include edapology and pedology. Ecology covers the interactions between the biota, with their natural environment. This field of study differentiates the study of the Earth, from the study of other planets in our solar system. The Earth being the only planet teeming with life. Hydrology described the marine and freshwater domains of the watery parts of the Earth. Major subdisciplines include hydrogeology and physical, chemical, and biological oceanography. Glaciology covers the icy parts of the Earth. Atmospheric sciences cover the gaseous parts of the Earth between the surface and the exosphere. Major discipline are meteorology, climatology, atmospheric chemistry, and atmospheric physics. Earth's interior, plate tectonics, mountain ranges, volcanoes, and earthquakes are geological phenomena that can be explained in terms of energy transformations in the Earth's crust. Beneath the Earth's crust lies the mantle, which is heated by the radioactive decay of heavy elements. The mantle is not quite solid and consists of magma which is in a state of semi-perpetual convection. This convection process causes the lithospheric plates to move, albeit slowly. The resulting process is known as plate tectonics. Plate tectonics might be thought of as the process by which the Earth is resurfaced. Through a process called seafloor spreading, new crust is created by the flow of magma from underneath the lithosphere to the surface, through fissures, where it cools and solidifies. Through a process called subduction, oceanic crust is pushed underground beneath the rest of the lithosphere where it comes into contact with magma and melts rejoining the mantle from which it originally came. Areas of the crust where new crust is created are called divergent boundaries, those where it is brought back into the Earth are convergent boundaries, and those where plates slide past each other, but no new lithospheric material is created or destroyed, are referred to as transform boundaries. Earthquakes result from the movement of the lithospheric plates, and they often occur near convergent boundaries where parts of the crust are forced into the Earth as part of subduction. Volcanoes result primarily from the melting of subducted crust material. Crust material that is forced into the asthenosphere melts, and some portion of the melted material becomes light enough to rise to the surface giving birth to volcanoes. Earth's electromagnetic field. An electromagnet is a magnet that is created by a current that flows around a soft iron core. Earth has a solid iron inner core surrounded by semi-liquid materials of the outer core that move in continuous currents around the inner core. Therefore, the Earth is an electromagnet. This is referred to as the dynamo theory of Earth's magnetism. Atmosphere. The troposphere, stratosphere, mesosphere, thermosphere, and exosphere are the 5 layers which make up Earth's atmosphere. In all, The atmosphere is made up of about 78.0% nitrogen, 20.9% oxygen, and 0.92% argon. 75% of the gases in the atmosphere are located within the troposphere, the bottommost layer. The remaining 1% of the atmosphere contains small amounts of other gases including CO2 and water vapors. Water vapors and CO2 allow the Earth's atmosphere to catch and hold the sun's energy through a phenomenon called the greenhouse effect. This allows Earth's surface to be warm enough to have liquid water and support life. The magnetic field created by the internal motions of the core produces the magnetosphere, which protects the Earth's atmosphere from the solar wind. As the Earth is 4.5 billion years old, it would have lost its atmosphere by now if there were no protective magnetosphere. In addition to storing heat, the atmosphere also protects living organisms by shielding the Earth's surface from cosmic rays. Note that the level of protection is high enough to prevent cosmic rays from destroying all life on Earth, yet low enough to aid the mutations that have an important role in pushing forward diversity in the biosphere. Methodology. Methodologies vary depending on the nature of the subjects being studied. Studies typically fall into one of three categories: observational, experimental, or theoretical. Earth scientists often conduct sophisticated computer analysis or go to many of the world's most exotic locations to study Earth phenomena. A foundational idea within the study Earth science is the notion of uniformitarianism. Uniformitarianism dictates that ancient geologic features are interpreted by understanding active processes that are readily observed. In other words, any geologic processes at work in the present have operated in the same ways throughout geologic time. This enables those who study Earth's history to apply knowledge of how Earth processes operate in the present to gain insight into how the planet has evolved and changed throughout deep history. Earth's spheres. Earth science generally recognizes four spheres: the lithosphere, the hydrosphere, the atmosphere, and the biosphere. These correspond to rocks, water, air, and life. Some practitioners include, as part of the spheres of the Earth, the cryosphere as a distinct portion of the hydrosphere, as well as the pedosphere as an active and intermixed sphere. Partial list of the major Earth science topics. C. List of basic Earth science topics: atmosphere, atmospheric chemistry, climatology, meteorology, hydrometeorology, paleoclimatology, biosphere, ecology, biogeography, paleontology, palynology, micropaleontology, geomicrobiology, geoarchaeology, hydrosphere, hydrology, geohydrology, limnology, oceanography, chemical oceanography, physical oceanography, biological oceanography, geological oceanography, paleoceanography, lithosphere or geosphere, pedosphere, soil science, edapology, pedology, systems, environmental science, geography, human geography, physical geography, Gaia hypothesis, others, cartography, geoinformatics, geostatistics, geodesy and surveying, NASA Earth Science Enterprise. See also Earth Sciences Graphics Software, Environmental Geoscience, GeoLEO, Glossary of Geology Terms, List of Unsolved Problems in Geoscience, List of Geoscience Organizations, List of Russian Earth Scientists, Nanogeoscience, Structure of the Earth, References. Further reading, Alabi M., 2008. Dictionary of Earth Sciences, Oxford University Press. ISBN 978-0-19-921194-4, Adams, Simon. Lambert, David. Earth Science, An Illustrated Guide to Science. New York, New York, Chelsea House. ISBN A0-8160-6164-5, Joseph P. Pickett. American Heritage Dictionary of the English Language. Boston, Massachusetts, Houghton Mifflin Company. ISBN A0-395-82517-2, Corvin G., 1998. Fractal Models in the Earth Sciences, Elsevier, ISBN 978-0-444-88907-2, Earth's Energy Budget. Oklahoma Climatological Survey. 1996 Euro 2004. Retrieved November 17, 2007 Miller, George A. Christiane Fellbaum. And Randy Tenji. And Pamela Wakefield. And Rajesh Poddar. And Helen Langon. Benjamin Haskell. WordNet Search 3.0 inches. WordNet, a lexical database for the English language. Princeton University Cognitive Science Laboratory /221 Nassau Street /Princeton, New Jersey, 08542. Retrieved November 10, 2007 NOAA National Ocean Service Education, Geodesy. National Oceanic and Atmospheric Administration March 8, 2005. Retrieved November 17, 2007 Oldroyd, David. Earth Cycles, A Historical Perspective. Westport, Connecticut, Greenwood Press. ISBN A0-313-33229-0. Reed, Christina. Earth Science, Decade by Decade. New York, New York, Facts on File. ISBN A978-0-8160-5533-3. Simerson, W. Bryan. The Mechanism Behind Plate Tectonics. Retrieved November 17, 2007 Smith, Gary A. Pun, Aurora. How Does the Earth Work? Physical Geology and the Process of Science. Upper Saddle River, New Jersey, 07458, Pearson Prentice Hall. ISBN A0-13-034129-0. Tarbuck E. J., Lutjens F. K., and Tasser D., 2002. Earth Science, Prentice Hall, ISBN 978-0-13-035390-0. External links, American Geosciences Institute, Earth Science Picture of the Day, a service of Universities Space Research Association, sponsored by NASA Goddard Space Flight Center. Geoethics in Planetary and Space Exploration. National Earth Science Teachers Association, Earth Sciences Degree Program Directory.